David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. Action. Today's lesson covers the variance of a binomial distribution. So let's review a few terms before we get started here. Standard deviation and variance. Now, standard deviation, we use the sigma to represent that, lowercase sigma, and variance is just another spread measurement, which is sigma squared. So whatever the standard deviation for a data set is, the variance is just that number squared. And these two measures tell us about how far the data is spread out from the mean, okay? Now we can also do this for a binomial distribution. Let's take a look at a formula for that. So if x, our binomially distributed variable, n trials, p is our probability of success, you can find the variance, standard deviation squared, by just multiplying trials times the probability of success times the probability of failure. And this gives us the variance for a set of binomially distributed data. Let's do a problem that will lead us into calculating the variance for a situation. But first we're going to review a few of the other types of calculations that we've done. So here's our setup. I've copied over our formula from the last board. A biased die, so it's not fair, it's going to give some different results, is rolled 50 times. 12 sixes are seen. If the die is rolled 12 more times, find the probability that a 6 is rolled exactly twice. Now pause the video, see if you can do a plug-in step for that calculation. All right, so here's my plug-in step. This is for us calculating the result for our random variable equaling 2. So that would be 2 times we get exactly 2 sixes in the next 12 rolls. So here's my combinatorics, 12 over 2. Here is my probability of success, that's 12 out of 50. That's what happened in our first 50 rolls. And we're doing squared because we want that twice. And then here's the probability of failure. It's just 1 minus that one, so that's 38 over 50. And that's to the remaining, the n minus r power, so that's to the 10th power. Now, at this point, you're going to use your calculator to evaluate these two terms. And then the combinatorics, you're going to have to do that as well. So go ahead, pause the video and do your calculations and come back when you get your probability that the successes are exactly 2. All right, so I did the combinatorics for you right over here. I got 12 factorial over 2 factorial, 10 factorial. Now remember, there's a nice shortcut. You don't have to expand this all the way out. Once you get to 10, you can just leave the factorial on it, because this means 10 times 9 times 8 all the way on down. Because then I get to cancel my 10 factorials right there without expanding them. So then I have 12 times 11 over 2, 132 over 2, which is 66. So that brings me back to my combinatorics term just being 66. I converted my fractions to decimals, and then I pumped that all into my calculator, and my probability is 0.244 or 24%. All right, I added our next prompt. Same situation, we're rolling the die 12 more times. Now what I want you to do is find the expected number of sixes. And that's the last lesson that we did. You might want to flip back through your notes, pause the video, do that calculation, and come right back. Okay, let's see how you did. The expected number of sixes, that's our little x, is just the number of trials times the probability of success, times the probability of getting a 6, as determined by our experiment where we rolled this loaded die 50 times. So that's just going to be 12 times 12 over 50, which ends up being 2.88 sixes. So that's how many we would expect in 12 more rolls. Okay, let's do the variance. Find the variance of the number of sixes. So that goes back to this formula. So pause the video. Plug-in step is pretty straightforward. Do that calculation and come back. Let's see how you did. So here we go. Here's my formula. Variance, which is standard deviation squared, is n times p times 1 minus p. We know all of these values already, so the plug-in step is really straightforward. Here's our n, we're rolling it 12 more times. Here's our probability of success, and here's our probability of failure. So I'm just converting those to decimals before I put them in my calculator, and I get 2.19 for my variance. Let's do a little bit more of an abstract example that has us solve for the probability of success. Okay, so here we go. Here's our randomly distributed variable, binomially distributed. We're doing 20 trials, and we don't know our probability of success. So there's our little p. But we do know the variance. The variance is 1.92. So now you're going to be asked, find the probability of success. So think about your equation for variance, do a plug-in step, and solve for p. All right, now, here is my plug-in step, my variance, or actually there's my formula. Here's my plug-in step. I just put in what I knew in my equation. Here I am working a couple steps down, one step down. Finally, I need to find p. And because of this multiplication, I get a p squared term. So now I'm thinking quadratics. So what I did is I scooted everything over to one side, set the other side equal to 0. Now I want you to pause the video and do a critical thinking step, maybe even solve this thing and figure out what the variance really is. All right, hopefully you realized that your calculator is the best tool for this task. You could factor and solve or use quadratic formula, but that might be a little difficult. So what I want you to do, check this out, by graphing with a graphing display calculator, what you're trying to do is you're trying to find the zeros or the roots or the solutions for this quadratic equation. So go ahead, pause the video, get out your calculator, put in this equation, take a look at the graph, and see if you can do those steps, and come back. Okay, when I put it in my calculator, here's the graph I get. I went and sketched it for you right there. I get an upward opening parabola because we do have a positive number on our squared term, and the intercepts are 0.108 and 0.892. So in this case, the probability can be one or the other of those. Now that seems kind of strange. I want you to think about that for a minute. Pause the video, take a look at how the calculation goes, particularly perhaps this step, and then come back. Okay, you get two results because the probability of success and the probability of failure always add to 1. So in this calculation, they could be switched. So you could have a 0.108 probability of success and a 0.892 probability of failure, but you're just multiplying those two numbers by each other. So we could switch those and it wouldn't change the result. So this is what happens when we're going backwards. Ultimately, we're going to take a square root to get the solution of this, and then every root has two possible answers. So in a problem like this, you're actually going to get two probabilities that satisfy the prompt. Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.